Welcome back. Blockchain tutorials for voice, where we are exploring the intersection of Web3 blockchain technology and voice-first artificial intelligence built on top of conversational AI. We're doing some intro learning right now, and this is part 3 of our session to create a to-do list app, full stack on top of the Ethereum blockchain. Today we've got 3 things left to finish out our application: testing, the creation of tasks, and the completion of tasks. Right now, we can read all the tasks on our to-do list, but we can't actually do anything. This is being read directly from the blockchain, and what we did last time is we set up this initial front end. We got the HTML code and the JavaScript code, and we ran that server locally. So now we're going to work on the next task of testing. Now let's write a basic test to ensure that the to-do list smart contract works properly. Let's first talk about why it's so important to test when you're developing smart contracts. 1, all of the code on the Ethereum blockchain is immutable. It cannot change. If the contract has any bugs, we have to disable it and then deploy a new contract. This new copy will not have the same state as the old contract. It will have a different address. Deploying contracts costs gas because it creates a transaction and writes data to the blockchain. This costs Ether, and we want to minimize the amount of Ether we ever have to pay. If any of our contract functions that write to the blockchain contain bugs, the account who is calling the function could potentially waste Ether, and it might not behave the way that they expect. Let's create a test file called todolist.test.js. Inside of our test folder, we'll make a new file called todolist.test.js. We'll write our tests in JavaScript inside with the Mocha testing framework and the Chai assertion library. If you're already building with Jovo, which is, in my opinion, the best programming framework to build voice applications, Jovo testing, this is going to look very familiar because Jovo also uses Mocha and Chai for its JavaScript testing. Mocha, Chai, I guess they don't talk about it here, but they do use Mocha and Chai. If you look inside of the required libraries, Jovo also uses Mocha and Chai. Big shouts out to Jovo. They are the best. They're open source. Build once any voice application and publish it on Amazon Alexa, Google Assistant, web chatbot, Twilio. Pretty much if there's a conversation going on, Jovo can deploy it there. These come bundled with the Truffle framework. We'll write all these tests in JavaScript to simulate client-side interactions with our smart contract, much like we did in the console. Here's the code for the test. Alright, so we've got a contract, a to-do list with accounts, to-do list. This is just like what we're doing inside of our console. It deploys successfully. To-do list.address not equal to address 0x0. We're asserting that the address actually exists, and then we list the tasks. So let's see what happens. Let's put this inside of our to-do list. So again, we've got our contract of to-do list. First thing we do is we get the contract that was deployed. Once we get that it deployed successfully, we then get the address from the contract. Once we get the address, we list our tasks. So we can do the same thing just like this, where I'm already inside of the Truffle console. So here I can go to-do list equals await to-do list dot deployed. Now when I print to-do list, we see this is the smart contract. This is the same as this. To-do list equals await to-do list dot deployed. So before anything happens, we want to actually get the deployed smart contract. Once we get that it's successfully deployed, then we get to-do list dot address. So if I log to-do list dot address, we get the address of the contract, which is actually equal to an Ethereum address. and then we assert that it's not equal to 0x0, an empty string, null or undefined. So we actually want this address to be something. And then finally we list all the tasks. So we'll get the task count, to-do list.task count. We have one task in there because it was just deployed to our new blockchain. Then we get tasks, which is equal to tasks of task count, so we get the last task. And then we assert that the ID of the task is equal to the task count. So we assert that the ID of the task is equal to task count. And then we're asserting that the content is equal to checkout.dappuniversity.com. This is not true because we have changed ours to be different. Task completed is false, and then task.toNumber is 1. So most of those checks will pass except for this last one. We'll keep moving forward and then we'll change this as needed. Let's explain this code. First, we require the contract and assign it to a variable like we did in the migration file. Next, we call the contract function and write all our tests within the callback function. This callback provides an accounts variable that represents all the accounts on our blockchain provided by Ganesh. The first test checks that the contract was deployed to the blockchain properly by inspecting its address. The next test checks that the smart contract lists tasks properly by checking the default task we created in the initializer function. Now let's run the test from the command line like this. We'll run truffle test, and then we should get that this failed. So we expected to equal that. Remember, I changed the initial constructor inside of our contract's to-do list code. We create a task called checkout at voice-first-AI. So if I take this description, I can then put it inside of our test, paste it there, and now let's try running the test again, and we should pass this time. This time, all of our tests pass. So we have a successful test that got run. So testing, now good. So now we know how to build tests for test suites to test our smart contracts before we deploy them to the Ethereum blockchain. Unlike Web 2, where we can just kind of do continuous deployment and keep on deploying, with Ethereum we really want to be intentional. We want to be aware of what it is we're deploying so that we don't waste resources, because we're not just wasting Google or Amazon's resources, we're wasting a decentralized network's resources, and it changes the entire mental model around how we build and deploy code. Next up, we finished 1 out of 3. 2, create tasks. We've already created a function for creating tasks, but it's not complete just yet. It's because we want to trigger an event anytime the new task is created. Solidity allows us to trigger arbitrary events which external consumers can subscribe to. It will allow us to listen for the events inside of our client-side applications. So let's create a task created event and trigger it anytime a new task is created in the create task function. So we've got an event which needs an ID, a content, and a completed. And then inside of our create task function, we're going to add that task created event. Let's try doing it. So inside of our to-do list smart contract, we will create an, I'll have this event be after our constructor. Event task created, it's just a normal task. And then we need the same variables that we passed inside of our task, inside of our event. And then once we have added that task, we then say emit task created, I think it's emit. We'll find out in a second. Then I'll pass in ID. I'm sorry. We'll pass in task count. How are we doing it over in our tutorial? Emit task created, task count content false. Emit task created, task count underscore underscore content, comma false. So this will emit this event, our task created event, and then we pass in the ID of task count. The content is content, and then completed is false. Now let's create a test to ensure that this event is triggered anytime a new task is created. We will inspect the transaction receipt when the new task is created. It will contain all the log information that will contain the event data. We can inspect this data inside our test like this to ensure that the event was properly triggered. So we want to add this section inside of our test. So after we list the task, we want create tasks. So first we create a task called a new task. Once we do that, we get the task count. We assert that task count is equal to 2. We then get the event that should have been triggered in the result of creating the task. And then we get the arguments from that for the event. So inside of that event, we then have an ID, a content, and a completed. We assert that the ID is 2. We assert that the content is a new task, and then that completed is false. I think that should be the last thing. Now let's run our truffle test. Truffle test. Okay, so task created, I did not initialize that event right. I'm glad that we are checking. Task created should have parentheses instead of curly braces. Just like it says here inside of my test. It says, hey, we expected a parenthesis, but we got a curly brace. So we'll go back to our smart contract code. We'll change these from curly braces into parentheses. It's not liking our ID for some reason. Maybe we need commas here. Looks like we might need commas here. There we go. Now everything's looking right. Let's try it again. Boom. It deployed the contract successfully. We listed the tasks, and then we created the task. And we also checked that the event was fired. Yay, they passed. Now let's deploy a new copy of the smart contract since the code has changed. So this test was run locally. We haven't actually deployed it to our blockchain, which seems like a very cool feature of Truffle, that we can test it locally, we can code it locally, we can do a lot of stuff locally without actually having to deploy our contract to the blockchain. But now let's go ahead and actually deploy it to the blockchain. I think I'll need to make this a sudo so that it uses root to deploy. Yep, we need a sudo up in here. So we'll add a sudo, type in my password. Now we deploy a new version of the smart contract to Solidity, or to the Ethereum blockchain locally, local version of the Ethereum blockchain. It has successfully deployed. Now let's update the client-side code. First we'll uncomment the form code inside of the index.html. So we want an onSubmit that triggers our create task function, and then have a new task input field. Let's go back to our index.html. Where is our form? Here is our form code. Uncomment that. Fix our tabs. So, reading through this, we've got a form that wraps around our inputs. Inside of our form, when the form is submitted, we trigger our app.createTask function, which we can see over here. The create task actually doesn't look like it exists over here, depending on what app is. We might need to add more code. Next, we'll add the create task function inside of our app.js. Okay, yeah, so now we need our create task code inside of our app.js. We'll add it down towards the bottom after set loading. We'll add it before set loading because it's already got the comma, whereas set loading does not. So our create, let's start back at our index.html. When we submit the form, we trigger our create task event. Our create task event changes our set loading state to true. We then get the value of our new task element. New task is right there, which is an input. So we'll grab whatever the task name is. We will then trigger our to-do list, which is our smart contract. We'll trigger the create task function with the content to actually create a task on the blockchain. After that, we then refresh our web page so that we get the newest and latest version of our smart contract state with the new transactions loaded onto it. Back to our index.html. So inside of our form, we have an input of new task. We already know that this is going to be the task text of what our task is on our to-do. And then our submit button, which is going to hit this on submit function to create the task on the Ethereum blockchain. Now you should be able to add new tasks from the client side. Notice there's no submit button on the form. I left it off. Simplify, you must hit the enter key on your keyboard to submit it. Once you do, you'll see a MetaMask confirmation pop up. You must sign the transaction in order to create a task. So we should have automatically updated the state. So let's type in first task from UI. And now something is probably going on. App.js line 117, the send transaction from field must be defined. App.js line 117. Okay, it's not liking that. The create task is not happening. I think it's crashing right after here. Let's let's do some console logs so that we can get more info. Content, $content. I have a feeling we're going to log this one where we get the content, but we're not going to log this one where we create the task. Let's see how it actually looks on our front end. First task from UI. Okay, so we actually did get that first task from UI log. The send transactions from field must be defined. I think it's supposed to look something like this. I'm not sure though. We're going to try this once, and if this doesn't work, we're going to run test. Yeah. Maybe I should be doing this. From field must be defined. Okay, and our tutorial does not talk about how we're supposed to do that. So let's just run a Google search to see what this error message means. If you're using contracts as your default account, modify the line. Okay. Or when you create your Web3 object, we can set our Web3 ETH default account equal to account 0. So let's try that. Let's try when we're initializing our Web3. I think it should be right here. So inside here, I think we want to set from account 0. Hopefully this will do it. Let's see. Hello world. Okay, so first I left some old code that we don't actually want down here. We don't want this send. Let's see if that fixed it. I'm doubtful. It looks like we got another error. From field must be defined. Okay. Let's try doing what they say here and add this into our function call in our app.js. Let's see what happens now. Accounts is not defined. Did we set accounts anywhere? It's always the bugs that take the longest. We did set app.account, so it's probably this dot accounts. Let's try it again. Provided address is invalid. Okay, so I'm still doing this wrong. How we're trying to create the task. So let's revert some of these changes and go back to how it was originally, so that we can kind of mute some of the noise. Okay, let's start from here. Looks like send transaction. Let's look up what we should be passing into this send transaction. And we'll do that by checking out the source code for this project, which should be at the bottom. We want to look inside of the app.js file to see. Looks like we're leaving it empty there. Very interesting. I don't actually see us ever setting an account, so this might be another render the account equals app.account. Brave browser. Default account. Okay. Yeah, this is actually the exact same tutorial that we're doing. And here's how we do it. I want to +1 this stack. Okay, so we'll add this into after we pass in our parameters, we can then pass in this object. I'm not sure if Web3 is defined here, but we will find out. The send transaction from field must be defined. I thought we just did. do it on the next line so we can compare the difference. I'm not seeing a difference here, so I think we were already doing it right, but my question is, why is it still giving us an error? We're signed into MetaMask. Oh. Your current account is not connected. Well, let's connect it. Okay. The send transactions from field must be defined on line 119. Line 119. I feel like I'm defining it. Console.log ETH account. So let's log our ETH account with $, curly braces. Let's see what we get when we log our Ethereum account. Okay, so it looks like our Ethereum account is null. That's an issue. Why is it null? Are we ever defining a default account? Let's see where all Web3 is defined. Okay, so we've got Web3 right there. I think we want to use app.account. Let's try logging app.account. Okay, it's still undefined. Something's going on here. Load contract, render. So we set stuff like app.web3 provider, app.account. Let's just alert web3.eth.account 0. It's undefined. Why is the event data is deprecated, deprecated. So we've got a lot of deprecated events. We do have an account. It should be connected here. So my question is, why aren't we getting that account? I think we could really optimize a lot of this code, and I think in a future tutorial I probably will. Because Web3 is changing very fast, so stuff that works when this was written back in 2019 doesn't work anymore. There's an article here. We'll quickly check it out to see if it's helpful. Okay. Not proving to be super helpful. Which appears due to recent MetaMask updates, and that moving from Web3 to window.ethereum, I was able to make this work using... Okay, so let's try changing web3.currentProvider. Control find web3.currentProvider. Let's try alerting, or let's just log console.log, less intrusive, web3.current Web3 provider. It's going to be $ web3.current provider. Let's see what this logs. Web3 provider is object. Let's JSON.stringify this. Okay, so we can't convert the circular structure to JSON. We'll just have 2 logs. Probably make it easier. Let's log that. Okay. So it does look like that works, but let's try changing it to window.ethereum. Okay. So these look very similar. I'm actually not seeing a difference in them, so I don't know if this actually would make a difference, but let's try implementing what they say in our method. Because we're also still logging that app.account isn't working. Let's comment both of these out and see what app.account is. Gonna comment out the window.reload because I don't want my comment to go away. Ethereum account is still undefined. Let's do what they say and switch it to window.ethereum anytime we have web3.current provider. Web3.current provider. I think we got them all. Let's make sure. Yeah, we got them all. Okay. So back over here. We're still getting that our Ethereum account is undefined. Why is our Ethereum account undefined? Let's try just getting our accounts. I just want this to work now. Starting to get frustrated. Alright, let's see what happens. Am I still in here with MetaMask? Should have an account connected to this web page. Okay, so now I actually got an account with that method. So let's log accounts 0. Okay. So it looks like we're making progress now. Let's uncomment one of these and delete the other one. And now in our from, let's paste account 0, and then we will remove the window.reloaded. Fingers crossed, this should be the working moment. although it's very kludgy. Boom. Pops up MetaMask. MetaMask asks us to approve the transaction. Transaction is approved. Then refreshes the page, and now we've got our new task. Second task from working UI. MetaMask asks us to confirm the transaction. We then get our transaction approved, and it's written to the blockchain. So we got it all working. I don't like how challenging this was to get working, so let's try to clean this up a little bit. Let's move this up here. Now let's try using app.account. Let's see if ETH account is now logged. And then we'll remove our reload for a sec just to make sure that we are doing it properly. Approve the transaction. Okay, so we're now getting a valid ETH account when we log it. So we can remove a lot of the stuff that we've done over here, and instead of using account 0, we can use app.account. We'll remove a lot of this. All the console logs, we don't need it anymore. We'll put our reload back in. What else do we want to clean up here that we added in? We've also added in, so this is the only line I think we needed to add in. Everything else should be the same from the initial tutorial. Yeah, so the only thing that we had to change from the initial tutorial is inside of the load account method, we needed to get all of the accounts in an await from web3.eth get accounts, and then set our app.account equal to account 0. And then, so we had to, 1, modify the load account to actually get our Ethereum address. And then 2, inside of the create task method, we needed to add this from field. To verify that what I'm saying is correct, let's add an additional task called final task of the day. MetaMask opens, asks us to approve the transaction. We approve the transaction. The window reloads. Boom, we got final task of the day. And all of this is written to the blockchain, and we can query it from any front end. This is just the front end that we're using. Okay, so we have already run tasks. We have also worked on creating tasks. Now we just need to have the option of completing tasks. So the last thing we'll do on this tutorial is check off the tasks in the to-do list. Once we do, they'll appear in the completed list. Strike through. First, we'll update the smart contract. We'll add a task completed event and trigger it inside a new task completed function. So we'll have a task completed event with an ID and then a Boolean. And then inside of our, we'll also have a task completed function with an ID of a task. So then we get a task from memory, from the blockchain storage. We then set the completed value of that task to the opposite of whatever it already is, using the not, the Boolean not. And then we update tasks. We write to the blockchain at the ID, the new task, the task from memory, the function memory. And then once we've updated that task, we then trigger the task completed event. First thing I want to do is create my task completed event. I'll put it beside my other task completed event. Event task completed. We'll use parentheses this time. And now we need a uint of ID and then a bool of completed. Now after our create task function, what's the name of the function we want? It's called task completed. So now we want a function called task completed with a uint of ID, of underscore ID, and we want this to be a public function so that it can be accessed by our client. Inside of that function, we will create a task from memory called underscore task because this is just stored in memory. And then we'll read from tasks of the underscore ID. So we've now created a task, I think. Looks like we did task memory task equal tasks underscore ID. Is tasks defined? Tasks is defined. Okay. Now we want to set underscore task dot completed equal to not underscore task dot completed. Now we want to update our task on the blockchain, so we'll say tasks of underscore ID equals underscore task. This is going to update our blockchain value with our local value from memory. And then once we've done that, we then want to emit the task completed event, and then the ID we want is underscore ID, and then completed, I think we want to be this. That way we're actually getting it from a value, but let's see what we're doing here. Yep, exactly the same. Okay, let's see what else we do. Next we'll write a test. I'm glad we're writing a test. So it toggles task completion. So we toggle completed of the first task, then we get the result, then we get the first task after we've updated the state. We then assert that task completed is true. We then get the event from the results to get the parameters of that task, of that event, and then that event has an ID and a completed. This all makes sense, but everything makes sense when you're reading someone else's writings. So the result is await this dot to do list dot task completed of 1, so the initial constructor. Then we get it, we assert that the task is completed, then we get the task completed event, we assert that that event ID is 1, and then we assert that that event completed status is true. I think next we want to run truffle test. Truffle test. This dot to do list dot toggle completed is not a function. Toggle completed, is it a function? It's not. I said task completed. So, and actually I'm going to call this complete task. And now let's insert this into our test. Let's try it again. Testing, testing, testing. Success, 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 success. We have successes across the board. We deployed our contract. We listed the tasks, which took 128 milliseconds. We created the tasks. It took 157 milliseconds. And then we toggled the completion, which is the longest test, almost half a second. All of the tests passed in less than 1 second. Now I think we want to deploy it again with truffle migrate reset. And I need to make this a sudo truffle migrate -- reset. Once we do that, we compile it, we deploy it, everything gets deployed. We've now updated the state. Now let's update the client-side code. First we'll uncomment the event listener inside of the render tasks function. Okay, so inside of our render tasks function, we want to uncomment this so that we are toggling our toggle completed function. Yep. Okay, and then I think we want to add a toggle completed function. So now when we check the box on click, we will toggle completed, which we'll add right after our create task function, toggle completed. We set loading to true. We then get the task ID from the name. We then run our to-do list .toggle completed function, which doesn't actually exist, and then we reload the window. This is what our tutorial wants us to do. Based off of our experience so far, I think we'll want to make 2 changes here. And I'll pause for a second while you try to think of what those two changes are. I think the two things we'll want to change are we're going to want to change the name of this method to complete task, which is exactly what we have in our smart contract. And second, I think we want to add a from field so that we can add a signature, a transaction signature to this. That's what I think, but let's find out. Let's keep moving through with the task. Now find a task and click the checkbox. Once you send the transaction, it'll check off from the to-do list. Okay, so let's see if it works. So first I'm going to add a task called Hello World. We sign the transaction. It adds it. We now have a task. Okay, now let's complete our checkout at Voice First AI task. It'll make us sign a task. Oh, no it won't, because toggle completed isn't a function, just like we thought. So let's just solve these one at a time. Instead of doing everything I think we want to update, first let's rename the name of the function. So we need to change toggle completed to complete task. Additionally, I think we want to add this from object after task ID, but first let's see if this fixed it. One step at a time. Check it. We're missing the transaction from field. So let's add the from field. Those were the two changes. Remember the two changes? We wanted to change the name of the method and add in our from field. We've now got both of those changes in. I think this will work now. Let's try checking checkout. Opens up MetaMask. MetaMask, we confirm the transaction, and then boom, we confirmed it. And our state has been updated, and we now have checked the task. What do you think happens if we uncheck a task? From my opinion, if we uncheck a task, nothing will happen because our toggle completed. Oh, it might actually work. It might uncheck the task. Oh, that's awesome. Okay, so it works both ways. We can check it and we can uncheck it. Let's check them both so that we can say tutorial is completed. So we're now running a full stack application on a local running Ethereum blockchain. Tutorial completed. Every time we want to actually do a transaction that writes to the blockchain, we have to put our signature on it. So we put our signature on that transaction, and then we can interact with that on the front end. We can approve all of our tasks from our MetaMask account, and we can sign tasks, we can sign transactions, and query to and from the blockchain. There were a couple hiccups in that tutorial, but overall, it was a really nice getting started guide to using the Ethereum blockchain and being able to write everything. Now, this smart contract is not deployed on the mainnet. Right now, there are a few different networks on Ethereum. There's the main Ethereum network, Ethereum mainnet, and then there are a bunch of test networks that Ethereum has, so we can deploy to test networks and test our things out on test nets. We didn't even deploy to a testnet, we've just deployed locally on Ganache. So none of this blockchain information is leaving our computer. Our entire blockchain is running on our computer with all the nodes running on our computer. There's only one node and it's our computer. The next step I would do is deploy this onto a testnet, so that way we can test it with test transactions and still not have to worry about transaction costs. And then once we're happy with our smart contract and happy with how the client interacts with it, then we can deploy it to the Ethereum blockchain and pay for those transactions. For me, I don't even think I want to deploy to the Ethereum blockchain. For the applications I'm building, the costs of deploying and transacting on Ethereum are just too high. Like current ETH gas price. Let's just see what the current Ethereum gas price. Looks like right now the Ethereum gas price is 40.3. I want to say that that's way, but let's check. Yeah, the average is about 30 way, which is about $1.41 to make a transaction. On the high side, it's about $1.64, so it's not super high. And on the low side, it's 82 cents. But it's not super high, but it's still really high. So for me, the blockchain I prefer to use is Polygon right now. The reason I choose Polygon is because its goal is to be a scaling solution for the Ethereum ecosystem. Everything on it ends up getting written back to the Ethereum blockchain using a bunch of different technology, like optimistic rollup, ZK rollups, so we can deploy onto the Polygon blockchain very cheap for less than a penny, so a cost savings of 100x at least. And then we're still leveraging the Ethereum as the settlement layer at the end of the day, which means that we're still leveraging Ethereum as a currency and Ethereum as security and for the technology. We're still trusting Ethereum. We're not off on another main chain like Polkadot or Solana. Our base chain that we're working off of Ethereum. However, rather than us writing directly to Ethereum, we're going to leverage a scaling solution that's built for developers like us, which in my case, what I prefer is Polygon. This is my personal preferred service, and I'm talking about this as a developer, not as an investor. Nothing that we're talking about in this tutorial is investment advice. This is purely from a development and coding perspective. So going back, the things we did in this part 3 tutorial is we set up our test suite. We created a to-do list test using the Mocha and Chai testing framework. We then updated our to-do list to have the ability to create a task from the front-end client. And once we added the ability to create a task, we then added the ability to complete tasks. So that's it for this tutorial. Check out other tutorials if you have any questions. We've got a lot on our YouTube page, as well as bundled versions of these YouTube videos on our Udemy course, which you can have a copy of the Udemy course for free if you can't afford it. Right now, I think it's $20 on Udemy. And if you have, for any reason, you can't afford $20, shoot me a message and I will send you a free discount so that you can take the course for free. Additionally, if you want to take this if you want to take this version from Dapp University, you can. I'm just going to warn you based off of what we just did. This is outdated. It's on an older compiler version that really can't be deployed anymore. So a lot of this stuff is outdated. It was initially written in 2020. So you'll probably want to take a more updated version of this tutorial so that you don't get frustrated with some of the stuff we got frustrated with. If I can see far, it's because I stand on the shoulders of giants. Keep on finding your voice. This is Sweets, signing off.